All right, so let's imagine for a second a future where farms are just buzzing with technology, making sure we've got plenty of food, on our tables. But picture this, the very tech that's supposed to keep those farms running smoothly needs protection itself.
Right.
That's the kind of problem solving we love to explore here. And today's deep dive is all about a brand new system for detecting fires in agricultural settings.
Wow.
We're talking a clever blend of the Internet of Things, those trusty embedded systems.
Yeah.
And a web interface. So slick, you'd think you were checking your social media.
It's really a fascinating intersection of that cutting-edge tech and then the age-old practice of farming.
Yeah.
You see, the world of smart agriculture is all about squeezing every ounce of efficiency and sustainability out of food production.
Exactly.
But even the most high-tech farm is vulnerable to the destructive power of fire.
Of course.
And in these vast, often remote environments,
right,
early detection can be the difference between a minor incident and a full-blown catastrophe.
Exactly. And this system is like having a 247 fire watch, constantly scanning for any sign of trouble.
Yeah.
So how does it work?
Yeah.
Well, they've got these sensors strategically placed throughout the farm,
Okay.
feeding data to a Raspberry Pi.
Interesting.
Now, I know what you're thinking, a Raspberry Pi.
Yeah.
Isn't that something you tinker with in your basement?
It might surprise you, but the Raspberry Pi is a real workhorse in this system.
Okay.
It's compact, energy efficient, and surprisingly powerful for its size.
Wow.
They chose it over bulkier, more expensive options because it's the perfect balance of processing power and affordability for this application.
Interesting.
Plus, you can program it with ease, which is a bonus when you're dealing with the complexities of a fire detection system.
So it's like the brains of the operation,
Chicken.
gathering information from the sensors and making sense of it all.
Yep.
But there's another piece of the puzzle, right?
Yes.
Something about converting signal?
Ah, yes, the analog to digital converter.
Okay.
You see those sensors out in the field?
Yeah.
They're speaking in analog.
Okay.
Think of it like a continuous wave of information, like the rise and fall of your voice when you're talking.
Gotcha.
But the Raspberry Pi, it understands digital. Think of it like Morse code, distinct pulses of information.
Okay.
That's where this converter comes in.
Yeah.
It acts as a translator, making sure the Raspberry Pi gets the message loud and clear
Interesting.
from those analog sensors.
Okay, so we've got the sensors, the Raspberry Pi brain, and a translator, making sure everyone speaks the same language.
Exactly.
Sounds pretty impressive. But before we get too deep into the techie stuff, let's talk about why this matters. Why is fire detection such a big deal in agriculture anyway?
Well, on a fundamental level, you're talking about protecting livelihoods and a vital part of our global economy.
Yeah.
Fires in agricultural settings can be absolutely devastating for farmers.
Right.
Imagine losing an entire crop to a fire. The financial losses can be enormous. We're talking about the cost of the crops themselves, the damage to equipment and infrastructure, not to mention the disruption to operations.
Right.
It's a ripple effect that can impact entire communities.
Right, and it's not just the economic risks that are worrisome, is it? We have to think about the environment too.
Absolutely.
Yeah.
Fires release harmful emissions into the atmosphere, contributing to air pollution and climate change.
Right.
They can damage ecosystems, leaving behind barren land that takes years to recover.
Oh.
They can even deplete valuable resources like soil and water.
Yeah.
It's a major setback for sustainability efforts.
So there's a lot at stake here. I guess traditional fire detection methods just aren't cutting it anymore.
You hit the nail on the head.
Right.
While traditional methods have their place, they often fall short in modern agricultural settings. They can be too slow to react.
Right.
They lack the integration with modern technology that we've come to rely on.
Yeah.
And let's face it, covering those vast expanses of land can be a real challenge.
Yeah, for sure.
This new system aims to bridge that gap by combining the reliability of embedded systems with the power and connectivity of the Internet of Things.
Okay.
It's like having a high-tech guardian angel watching over the farm.
Now let's zoom in on those sensors because they're the real heroes in the story, aren't they?
Yeah, they are.
We're talking about the KY026 flame sensor and the MQ135 smoke sensor.
Right.
Can you give us a breakdown of what each one brings to the table?
You bet. The KY026 is your frontline soldier, specifically designed to detect flames. It's incredibly sensitive to the infrared light given off by fire, and you can even fine-tune its sensitivity.
Oh, wow.
Depending on the environment, think of it as having adjustable eyesight for fire.
That's pretty cool.
Then you've got the MQ135, the smoke detective.
Okay.
with a wide detection range that can pick up on smoke from various sources.
Yeah.
That's important because not all fires start with a visible flame.
Right.
Sometimes it's that telltale wisp of smoke that gives them away.
Yeah.
So they've got all angles covered. These sensors are constantly on patrol, sending their intel back to the Raspberry Pi. We've talked about how the Raspberry Pi is like the brain. But what exactly is it doing with all that data? It's not just sitting there collecting dust, is it?
Not at all.
Yeah.
Remember that Flask application we mentioned earlier?
Yeah.
Well, that's where the Raspberry Pi sends its findings.
Okay.
Think of Flask as the conductor of an orchestra,
Mm-hmm.
coordinating all the different parts of the system and presenting the information in a way that makes sense.
Right.
It takes the raw data from the sensors, analyzes it using clever algorithms, and then prepares it to be displayed on a user-friendly web interface.
So it's like taking a bunch of raw ingredients and turning them into a delicious meal. You can't just eat raw data.
Right.
You need to process it and make it digestible. But
Right.
what about the end user, the farmer?
Right.
How do they actually interact with this system?
That's where the web interface shines. It's designed with the user experience in mind, using a combination of HTML and CSS to create a visually appealing and user-friendly dashboard.
So it's easy to use.
Imagine a sleek control panel that gives you a real-time view of what's happening on your farm.
Okay, so it looks good, but what about the functionality? Can you walk us through some of the features that make this interface so special?
What's really impressive here is the real-time data visualization. Farmers can see sensor readings, system status,
Like what kinds of things?
things like the Raspberry Pi's performance,
Okay,
and of course the all-important fire detection status,
right.
all in real time. We're talking dynamic graphs, charts, clear visual indicators, anything to make it easy to spot potential problems.
So it's like having a high-tech command center right at your fingertips. I love that they've made it accessible too. You're not tied to a desktop computer in some office.
Yeah.
You can access this interface on your laptop, tablet, even your smartphone. Imagine you're out in the field, miles away from your computer, and you get an alert that one of your sensors has detected smoke. You can pull out your phone, check the interface, and assess the situation immediately.
That's right. That kind of accessibility and real-time information can be crucial in responding quickly to a potential fire.
Yeah. But this brings up an important point about data security.
Oh, yeah.
We're talking about sensitive information here.
Right.
The location of sensors, real-time farm data.
Of course.
How does the system protect that data from unauthorized access?
That's a great question. They've taken data security very seriously.
Good.
The system has built-in security measures like login authentication, so you need a username and password to even access the interface. It's like having a digital lock on your farm's control panel. And to further enhance security, they're using something called secure data transmission methods.
Okay.
Think of it like sending a message in a sealed envelope.
Yeah.
Only the intended recipient can open it and read the contents. It's good to know they're taking those precautions because data security is paramount these days.
Absolutely.
So we've talked about the technology, the importance of fire detection in agriculture, and how this system makes it all happen. But how do we know this system actually works?
Yeah.
Is it just a fancy concept, or can it hold its own in the real world?
Well, they didn't just design this system and call it a day. They put it through its paces with a month-long experiment back in January 2024. They wanted to see how it would perform under real-world conditions.
Oh, wow.
So they conducted a series of rigorous tests.
And what were the results? Tell me. They didn't just set a pile of hay on fire and call it a success.
Of course not. They did things like simulating high-load conditions and multiple users accessing the system at the same time. They wanted to make sure the system wouldn't buckle under pressure, and you know what?
What?
Passed with flying colors.
That's good to hear. But what about the accuracy of those sensors? Could they actually detect potential fires?
Absolutely. The system consistently detected potential fires and provided accurate readings from the sensors. It's not just about raising a general alarm.
Right.
It's about providing specific, localized information so farmers can pinpoint the source of the problem and respond quickly.
And what about that system monitoring feature we talked about earlier?
Yeah.
The one that keeps tabs on the Raspberry Pi. Did it actually provide useful information about the system's performance?
You bet. The interface displayed real-time data on the Raspberry Pi's CPU usage, memory usage, and even its temperature.
Oh, wow.
It's like having a health monitor for the system itself. If something starts to go wrong, you'll know immediately. and can take steps to fix it before it becomes a major issue.
That kind of transparency and real-time monitoring is essential for any system that's critical to operations.
Yeah.
It's not just about detecting fires, it's about ensuring the system itself is running smoothly and reliably.
Exactly, and here's another cool thing. They made the thresholds for normal and urgent fire status customizable.
What do you mean by customizable threshold?
Well, not all fires are created equal, right?
Right.
What constitutes an urgent situation can vary depending on the crops, the weather conditions, and a whole host of other factors.
Yeah.
So they designed the system with flexibility in mind during their tests. They set the threshold for smoke detection at 50% and for flame detection at 48%. That means if the smoke sensor detects smoke levels above 50% or if the flame sensor detects a flame signal above 48%. The system triggers an urgent alert, but those values aren't set in stone. A farmer can adjust them to fit the specific needs of their farm.
That's a smart move and allows farmers to tailor the system's sensitivity to their unique circumstances. So it's not a one-size-fits-all solution. It's adaptable to different environments and needs. It sounds like the system has a lot of potential, not just for agriculture, but for other applications as well.
That's what I was thinking. We've seen how it can be applied to agriculture, but what other areas could benefit from this kind of technology?
Yeah.
What other critical infrastructure could we protect using a similar approach?
Like what?
Think about forests, warehouses, even data centers. These are all places where early fire detection can make a world of difference. And with climate change increasing the risk of fires in many parts of the world, the need for reliable and adaptable detection systems is only going to grow.
Yeah, it's like we're at a turning point. Technology can step in and become a true guardian of our planet and our future.
It really is amazing.
This fire detection system is a perfect example of what's possible. When we combine ingenuity with a sense of urgency.
It really highlights how different fields can come together to create something truly impactful. We're talking agriculture, embedded systems, web development, and cybersecurity all rolled into one. It's a reminder that sometimes the best solutions come from thinking outside the box and finding creative ways to use existing technologies.
Absolutely, and it's not just about the technology itself.
Right.
But the way it's designed to be user-friendly and accessible, that's what makes it so powerful.
I agree.
Putting that control and that knowledge directly into the hands of the people who need it most.
Okay, let's take a moment to recap what we've learned in this deep dive.
Okay.
We've explored a new system for detecting fires in agriculture, a system that uses a clever combination of sensors, a Raspberry Pi brain, a signal translator, and a user-friendly web interface to provide real-time monitoring and alerts.
We've talked about why fire detection is so critical in agriculture, not just from an economic standpoint, but also from an environmental perspective. Traditional methods often fall short, but this new system offers a proactive and adaptable solution.
And we've seen how this system has been put to the test in real-world scenarios, proving its accuracy, reliability, and user-friendliness.
We've even touched upon the potential for this technology to extend beyond agriculture, protecting other critical infrastructure in a world that's increasingly vulnerable to the threat of fire.
So what does all this mean for you? Well, if you're involved in agriculture, this system could be a real game changer, giving you a new level of control over fire safety and peace of mind, knowing that your crops, your livelihood are protected.
But even if you're not directly involved in farming, this deep dive gives you a glimpse into the exciting world of smart agriculture and how technology is shaping a more sustainable and food-secure future for all of us.
Absolutely. We've seen how innovation can spring from unexpected places, blending seemingly disparate fields to create something truly remarkable. It's a testament to human ingenuity and our ability to find solutions to even the most complex challenges.
And as we wrap up this deep dive, I want to leave you with a thought-provoking question.
Okay.
If this system can be so effective at protecting farms from fire, what other applications are out there waiting to be discovered? What other challenges can we address by harnessing the power of technology and human creativity?
That's a great question.
That's something to ponder as we continue to explore the possibilities of a smarter, safer, and more sustainable world.